The alkali metals are in group 1 in the periodic table: lithium, sodium, potassium, rubidium, cesium, and francium, amongst the most exciting elements that exist. Only the first 3 are safe to keep in the school lab, and the rest are violently reactive. This video will concentrate on trends in their physical properties, their chemical properties, and why they react in such similar ways. The alkali metals are not your typical type of metal that you would find in coins, for example. Like all metals, they are good conductors of heat and electricity, but they are softer than most other metals. You can actually cut them with a butter knife. They are lighter than most other metals. It's a term that we call low density. They actually float on water while reacting with it. They have low melting and boiling points compared with most metals. Now, a common type of question that will come up in the Gcse is identifying trends, and the examiners love to use tables to test whether you can read data. It's really important when you have a table with numbers that you use terms like increases or decreases. If you're talking about softness, that's okay. You can talk about the alkali metals becoming softer as you go down the group. The density increases and the melting points decrease. Next up, their chemical properties, and you most likely have seen this in the laboratory. It's a very common demonstration for teachers to give to their students. The reaction with water of all 3 metals is violent. The 2 products are hydrogen, which is a gas, and the metal hydroxide. For example, when sodium reacts with water, it gives sodium hydroxide and hydrogen. You can use the universal indicator in the water to prove that you form an alkali. It's important for you to be able to identify that as you go down group 1, there is an increasing reactivity. Lithium floats and fizzes, but it tends to keep its shape when you add it to water. Remember, it does float because of its low density. Sodium, however, shoots much faster across the water. It actually forms a ball. Potassium melts with the heat of the reaction, and the hydrogen catches fire. It sets off a wonderful lilac flame. If you heat the 3 metals and plunge them individually into gas jars of chlorine, they burst into flame. As you go down the group, the reactivity increases. They burn brightly, forming chlorides. This picture shows an example: sodium and chlorine reacting to form the compound sodium chloride. Sodium chloride is ionic. It consists of positive sodium ions and negative chloride ions. The reactions with oxygen are also very similar across all 3 metals. They all burst into flame when you heat them and plunge them into gas jars of oxygen. They burn fiercely to form oxides. The oxides dissolve in water to give alkaline solution. You see the same trend in reactivity shown in all 3 reactions. Here is a summary of the last 2 reactions. You have to be able to predict what the products are of reacting any of the alkali metals with chlorine and with oxygen. Pay special attention to the fact that the oxides dissolve in water to give alkaline solutions. Finally, you must be able to suggest that the reactivity increases as you go down the group. A common question that examiners will ask you is, why is it that elements in a particular group all react in a similar way? Whether it's for group 1, whether it's for group 2, or for group 6 or 7, the answer is the same. Atoms with the same number of valence electrons react in a similar way. Why does reactivity increase down group 1, the alkali metals? Is because group 1 atoms lose their outer electron to gain a stable outer shell. The more shells there are, the further the outer electron is from the positive nucleus, so the easier it is to lose. And the easier it is to lose an electron, the more reactive the metal will be. Can you explain this now yourself? The alkali metals are the most reactive of all the metals because they only need to lose 1 electron to gain that stable outer shell. They have that strong drive to react with other elements and compounds in order to give up this electron and become singly positively charged ions. The compounds they form are ionic. Thank you very much for watching the video. I really wish you the best of luck with your exams. Please don't forget to leave a like and subscribe to our channel. Take care. Bye.